Good morning, good afternoon, good evening to Fourthers all around the world. I'm Bill Ragsdale, the founding president of the Fourth Interest Group, and I help guide its activities for the first several years. And I'm glad to be doing Fourth again after 45 years. So today we're going to investigate the world's smallest robot. What in the world could that be? Well, we're going to create a robot using software, and then we're going to teach this robot his name, and we're going to teach him a motion to execute, and then he will teach that motion to another robot. So we have creation, we have christening, we have education, and we have further teaching. This is based on everything I know about object-oriented programming in 16 minutes. Which means I really don't know that much about object-oriented programming, just enough to generate this one application example. It is based on Win32 Fourth, which I've had the pleasure of using now for the last 25 years. It was created by Andrew McEwen and Tom Zimmer. And as you all know, I am writing a book based on Win32 Fourth. The basis of object-oriented programming is three components. First, there are objects. Objects are anything you can think of. They may be a person, they may be an action, they may be a database, they may be stored information. And objects not only contain that information base, but they also contain execution code. Methods is the name for that execution code. And above all is the class structure and the definer. We'll see how a class is created and how individual objects are created from that class. So we'll jump right into the application. Today we have a definer named robot, and the robot, when executed here, followed by the name of the object, in this case is Igor. So we now have created an object named Igor. And we take that same creator and apply it to create a robot named Robbie. This is the source code for that creation. We see :class, which is the class creator, and following it in green is the name robot. So that becomes the name of the class. And also, as we'll mention in a moment, this is also a creation word. The word super following it, then object means that robot takes its characteristics from the word object, and in addition adds its own. So robot is a defining word, and it has its own internal execution methods. And in the fourth terms, think of the word create does, because the word robot does creation and it does execution. So now that we have Igor, let's ask Igor what his name is. So who is a message, you as an operator, and it passes to Igor. And back we see in green is silence, because Igor does not know his name. So let's teach Igor his name. The S quote Igor leading into name : passes that string to the object Igor, and Igor has now learned his name. So if we execute who again, we will see in green, my name is Igor, it's his response. The code to do this is written mostly in Fourth. The :M followed at the very end by the semicolon M means this is a method. It behaves just like a colon definition does, but it has a wrapper around it that allows it to exist inside the object. So in this case now we have a variable called name, and the cfetch pulls the first character of that name. We examine to see is it a 0 or is it a value. And if executes, it means there is a numeric value there. So we do have a name. The output display then is :quote, my name is. Name accesses that storage area, count byte types the name Igor. Else, if there is no name, then we see the :quote and silence, which would output. So learning the name and speaking name is very straightforward. Learning the name is even simpler. In this case, we see the :M name. This is past the string from that .s. We've got the string of Igor. Name generates the storage area, and place puts that string in the storage area. So there we have how Igor learned his name. Now we're going to teach Igor a motion. Igor has a motion space that is tracked by right and left and by up and down, two-dimensional space. So we're going to pass to Igor a motion in that space. It's 10 and minus 77. They come in on the string. It passes to learn. Earn accesses Igor, and it executes the code for learn, and Igor has now learned his motion. We're going to ask him to act. So when we command act to Igor, he will then execute right by going up and down by 77. As we see the right up 10 and pardon me, the right 10 and up minus 77 means down 77. After Igor has made that motion, we want him to restore to his original position. So we execute command, pass it to Igor, and now it will move right down 10 and up 77, coming back to his origin. Here's the code that was derived from, the method for learn. Think of values in fourth. Up is a value and right is a value. So we pass him a number, and 2 up places it in up. Then the next stack value is passed to right and stored there. So remember, these are stack order, which is reversed. So the minus 77 is most accessible on the stack. That's placed in up. The 10 is placed in the value right. To act, the method for act is to display the word right, then access the value right. It will yield its value, which is 10, dot prints it. The dot quote up displays the word up. We access the up value, dot prints it out, and we'll see the minus 77. The restore is a mirror image of that. In this case, the right motion accesses the right value, and we negate that, minus it, and then output with a dot. We get the up motion, negate that, and output that with a dot. So again, we see that in general, the methods are really quite straightforward. They're very linear, very simple. Now, the final phase is that Igor wants to teach Robbie. So if we send the message to Igor of teach, it will generate the motion 10 and minus 77. Those values are passed as a message using learn to Robbie, and now Robbie stores 10 and minus 77 as his motions. And so let's see how Robbie executes. When we say act, and now we specify Robbie, how does he act? Again, he will echo back. He's going to go right 10 and up a minus 77. So notice how the word act is useful for both robots. On the other hand, each of them has their own copies of the variables right and up. The restore motion for Robbie is just as we would expect, right minus 10 and up 77. The teach word we've already seen. In this case, the output is we access the right variable, put it on the stack, access the up value, put it on the stack. So coming out on the stack are just the 10 and minus 77, and then learn absorbs those. So again, the first value goes to up, the second value goes to right. So this is how Robbie has taught using one method, and how it has learned using another. We'll look now at the software that is the basis of this entire activity. It generates these two robots and gives them their intelligence. The word :class generates the word robot. And remember, this is like Bill's does. Robot will define and it will also execute. The super object after it says that it itself is an instance of as an object variable, and it inherits characteristics from that word object. However, we're not using any of those characteristics today. Here's the declaration for its variables. Now, we declare first an integer as right, an integer as up, and then 100 bytes as a name. And remember, each object generated by robot has its own copy of these variables. So they are independent. The methods here appear as in this block definition. So we see the definition of who that teaches it, that reports its name, either name or silence. The name report access the name variable and places it in, puts it in place. The words to learn, the words to act, the words to restore, and the words to teach. At the very end is the semicolon class. Now, again, class is patterned after the colon definition, but there's a lot of wrapper that goes around this. There's a very large amount of structure that encloses these, and it gives them their intelligence. This is essentially a typed language because the words write, up, and name automatically know what their execution process is. The write and up yields a value, and name yields an address. So in this, the object orientation system supplies the typing and the pairing up of the operations and operators. Let's see what support Win32.4 provides. First, the word .classes will display all of the classes that have been created. Now, the only one we have created is robot, and you see the multi-status bar and the status bar, and there are about 20 more of the objects of the classes that exist in this system, and they're used for the user interface. If we want to explore robot, we then execute cmethods robot, and that will give us a listing of the methods that are associated with robot: teach, learn, restore, who, act, and name. To explore learn, we type MC learn, and make sure it is with the object Igor, and it will disassemble from memory the method. So this is not from source code, it's taken from memory. And so we see learn as the 2-I. Now the 2-I is what does the typing. This is the execution value that retrieves the value of that particular the variable follows it up. The 2I executes and it retrieves the contents of the following value, which is right. And finally, if you just enter the word objects, this will give you objects associated with robot. It will tell you that object has created Robbie and Igor. So you see, when I talk about there's a lot of wrapper going around all of these words. They are in an environment with linkage horizontal and vertical to tie it all together into a very functional, very self-contained system. So some of the fine points. We've seen that colon class creates in a hierarchical fashion that following the word super, there will be a super class and its characteristics are passed down to the class being generated. So the colon class robot falls on object for its higher level. Each of the methods name is called a selector, and they are required in Win32.4 to enter a colon. Not necessarily required, but to be able to differentiate them from colon definitions, we always affix the letter colon following their name. Methods accept stack values. They're numeric and string values. The string values are normally passed as an address and a count. So everything coming into the methods is on the stack. This, as we know in Forth, provides a very simple linking method between objects. The syntax for a selector is a series of parameters on the Forth stack, executing the name selector, and then it looks to the following object name to know where to direct the method. So, summarize, use your imagination. We did a very simple example today, all on one block of code. It simulated actions of generating a robot, teaching and learning, but instead of just outputting those actions to the display, imagine if the robot object, the commands link out to other objects. So it would pass methods to the other objects. And if those objects managed servo mechanisms, we would now be able to directly execute those physical motions. So there would be an arm object, for example, and to do the motion, Robbie would pass those two values to the arm, and the arm method would have methods internally on how to talk to the servo mechanism. So we see that object-oriented programming allows us modularization. We localize complexity. We have structured control flow, clear factoring, and code sharing. Now, the commercial is that all of these are a feature of Forth also, so that you might say Forth had a 20-year jump on object-oriented programming, but the object-oriented programming provides a much friendlier environment for Forth and a degree of structure and discipline. So I thank you very much, all. It's been a pleasure to talk to you this evening. And so I'll return to Kevin, our fearless leader. Thank you very much.